My name is Olivia Wu, and I will be one of your hosts for tonight.
Hi, I'm Joshua Lee and another one of your hosts.
Hi, I'm Samuel Shi, and I will be our final host for this evening.
We are part of the program BranchOut. BranchOut is a nonprofit program with Veritas Education Leaders that was co-founded by Dr. Yusin Wu and Mr. Richard Wang in 2015. The organization has grown from 20 student volunteers to over 150 student volunteers in 4 short summers. Our high school student mentors come from over 40 different schools across 4 states.
We started out as a peer STEM mentor program, looking at community centers, homeless shelters, county summer credit recovery programs, and I've expanded into a community outreach program to promote cross-cultural understanding by featuring community heroes, creating research articles, and organizing community workshops. As an award-winning community engagement program, we have received endorsement from U.S. Congress, including Senator Tim Kaine and former Congresswoman Barbara Comstock. Additionally, our Innovator program won the U.S. Congressional App Challenge Award 4 years ago.
As part of BranchOut's goals to promote civic engagement, community, and STEM education, we're extremely glad to have you here with us today. Artificial intelligence is rapidly transforming the way we work, create, and interact. Tonight, we have assembled a diverse panel of experts to explore how AI is specifically affecting different industries.
We are delighted to welcome our distinguished panelists today. They will share their expertise on artificial intelligence, its profound impact on our daily lives, and its potential to shape our future.
Our first panelist is Dr. Philip Frana. Dr. Frana is Professor of Interdisciplinary Liberal Studies and Independent Scholars at James Madison University. His current scholarly interests focus on the social and cultural aspects of artificial intelligence and information technologies. He is editor and contributor to the Encyclopedia of Artificial Intelligence and past project director at the Charles Babbage Institute for Computing, Information, and Culture. Areas of expertise include software and information studies, computing and culture, creativity, and individualized and interdisciplinary education.
Our second panelist is Dr. Huaxia Wang. Dr. Wang is currently working as an assistant professor at Rowan University, Glassboro, New Jersey. His research interests include image processing, wireless communications, cognitive radio networks, and deep learning. He was the recipient of the Outstanding PhD Dissertation Award in Electrical Engineering and the Edward Peskin Award with the Stevens Institute of Technology in 2018. He was also an assistant professor at Oklahoma State University in Stillwater from 2020 to 2023.
Our third panelist is Dr. Michael Klein. Dr. Klein is a professor of interdisciplinary liberal studies at James Madison University. He's the founding coordinator of the cross-disciplinary minor in medical humanities and teaches courses in technical communication, culture, and technology. A co-editor of the Encyclopedia of AI, his current scholarship focuses on technological literacy in the classroom and the cultural effects of AI.
Our fourth and final panelist is Dr. Grace Lindsay. Dr. Lindsay is a computational neuroscientist and author. She's a professor of psychology and data science at New York University, where she is also the head of Lindsay Lab. Her work uses artificial neural networks to understand the brain, and she is also interested in studying the control and effect of attention on sensory processing. She's faculty in the Center for Data Science and is focused on machine learning for climate change application.
To start this panel, we'll begin by asking some general questions. If any of our panelists have any thoughts, please feel free to unmute and share them. Our first question is, what inspired you to use AI in your research?
Dr. Wang, would you like to start us off?
Yeah, okay. So let me start with, hi everyone. My name is Huaxia Wang, and currently I'm working as an assistant professor at Rowan University, and I'm glad to be here to share my research and also thoughts about AI, especially in my research domain, the electrical engineering. So the first question is what inspired me to the AI in the research? So I can tell you the story for my learnings. So I started the information engineering when I was an undergrad. So that is purely working on the wireless communications. So for the wireless communication research or study, you only focusing on the signal processing, the Fourier transforms, so nothing related to AIs. And then I came to America to continue in my PhD study, and I still focusing on the cognitive radio, or so some kind of the 5G communication systems. But I get a chance because my school located in North Jersey, and I get a chance to do the summer internship in Bear Labs. So Bear Labs located in the St. Louis, Jersey. So the Bear Lab is a pioneer for the communications and technology. So they pioneered in the 5G, not only the 5G, but also 3G, 4Gs. And in the Bear Lab, even though it is a company focusing on the wireless communication development, but they do have a lot of the engineer have the open-minded sides. They have the eyes to looking at the new state-of-the-art technologies, including the AI. So I'm lucky to get a mentor, and he is a computer science engineer, but he's still trying to looking at some graph theories to working on the communication systems. So I started working with him. I self-started learning the AI, some convolutional neural networks, deep learning technologies, since I was summer internship in the Bear Labs. And after I back to the internship, I back to my advisor. I told my advisor, okay, we definitely need to looking through the AIs, the deep learnings. It's gonna be the future, not only for the computer science people, it also be the future for the electrical engineering, especially for the wireless communications. So since then, I started thinking about what kind of the traditional communication problem can be solved through the advanced AI technologies. So one of the example I'm using was because we know that the AI was very successful for the imaging classifications, right? But for the communications, most of the data we are facing is a time series data. So when I thought about, okay, do we have any image classification similar tasks in the wireless communications? Yes, we do. We do have the modulation classification. So and we apply the convolutional neural networks, the deep learnings, to that specific problems and get a very successful results. So that is actually motivate me to continuing this kind of the research. That is my current research focus is also how to combining the AI to the current wireless communication system design. Yeah, so that is a very short story about myself and also my inspiration for the AI in my current research. Yeah, thank you.
Thank you, Dr. Wang. That's very interesting. Dr. Lindsay, how about you?
Yeah, so my background is in neuroscience, and I'm interested in understanding the brain and particularly building computational models that can kind of replicate things that the brain does in order to understand how the brain works. And I was doing my PhD and studying the visual system and building models of how the brain's visual system works. And this was around the time that advances in computer vision were happening in the AI side. And there's actually a long history of relationship between the study of biological vision and artificial vision. And during my PhD, people came to realize that these computer vision models that were all of a sudden working very well could actually serve as a good model of biological vision. And you could actually predict the response of the brain to different images by using the response of an artificial neural network to the same images. And so that was happening when I was doing my PhD, and I thought, well, this is really interesting. It's kind of an approach to modeling the brain that isn't what I had been using, but I thought it could be really powerful. And so that's how I got interested in this kind of what's now called neuro AI intersection, where people who want to understand the brain can use tools from AI to build models that are meant to be more brain-like and can work at that intersection. So that's how kind of the AI tools became part of my research. Subsequent to that, more recently, I wanted to find some way that I could do some sort of research that would help with climate change. And because I had this kind of computer vision component of my biological research, I was able to use those skills to now work on problems where I analyze satellite imagery because it's a computer vision problem. So there's kind of this overlap of the computer vision skills that I can use to model how the brain works, and then separately also use to analyze satellite imagery.
Thank you so much, Dr. Lindsay. That's really interesting insight on neuroscience computational models. And it's so cool how they're able to replicate what the brain does and further understand how the brain works. Let's go to Dr. Frana. Any thoughts?
Yeah, good evening, everybody. So I'm actually trained as a humanist and a social scientist. My doctorate is in the history of technology, science, and medicine. My bachelor's degree was in economics. And I got interested in artificial intelligence as the software history project director for the Charles Babbage Institute for Computing, Information, and Culture at the University of Minnesota. And what that project was all about was interviewing and conducting oral histories with pioneers in the history of computer software, including AI pioneers, all of the pioneers that were still living who have won Turing awards in particular. And that led to all sorts of other interesting projects for me. Including today, I'm a digital technology specialist at the Geotech Center of the Atlantic Council in Washington, D.C., which is an international affairs think tank that's affiliated with NATO, the North Atlantic Treaty Organization. It's one of the oldest think tanks in the United States. And so I do research and writing for them. The latest project that I just finished was about AI responsibility in Singapore, but I've also written about the political economy of quantum artificial intelligence in healthcare, assessments of artificial intelligence in the rise of the digital attention economy, like social media and so forth. So have also written a bit and done research on quantum AI and climate change in a recent piece called Quantum Planet Hacking. So trying to pinpoint and develop solutions to human-caused environmental challenges using artificial intelligence, and also how artificial intelligence might be contributing to the problem.
Yeah, I really liked your response and how you and Dr. Lindsay, you're both kind of using AI to help combat climate change. And Dr. Klein, so I know we've asked this question a few times, but how has AI affected the way you do research?
Well, hello, everyone. Thank you for having me. I came to AI via popular culture. When I was working on my PhD in science and technology studies at Virginia Tech, I was looking at the way the cloning of Dolly created a scare about the possibility of cloning humans. And I was looking at the arguments people were making that were grounded in science fiction, such as in Blade Runner or Frankenstein or Brave New World, and how they were ignoring the science and going directly to these worst case scenarios. And ever since then, I've been interested in that interplay of culture and technology and how they are mutually reciprocal and affecting one another. I also have a background in composition and technical communication. So, of course, with the advent of ChatGPT, there's been quite a worry within the writing studies community that students will no longer do their own work, but will just use ChatGPT or one of its imitators to turn in as their own. We're also worried within the discipline about faculty members being replaced by artificial intelligence to teach people how to write. So that's where my focus has been and how I came to this.
Yeah, so I think it's really interesting how you mentioned how AI is being used a lot in schools because, I'm a student right now and a lot of us panelists are students and we just hear about how AI is used in assignments and stuff. So I think it's really important how you touched up on that. Thank you to all of our panelists for your insight on these questions. Moving on, Dr. Frana, this question is specifically for you. So I know that you already talked about how AI is being used to combat climate change. And can you just expand a bit on what ways AI is already being used to promote sustainability and how you hope to use AI to help the climate?
Sorry, sure. Happy to share. So there are actually lots of ways that artificial intelligence is helping us combat climate change in particular. And oftentimes this is called bright green AI. They're sort of like the dark green environmentalism that's, where it's low tech or no tech. But bright green environmentalism is about using technology wisely to try to address climate problems and environmental challenges. So there's a whole field that's called computational sustainability, which is about studying the impacts of human overdevelopment on the environment. You probably are familiar with or have seen sort of some of the fruits, the user end results of this are things like there are apps that have been developed. For example, Cornell University's Laboratory of Ornithology uses the eBird app, and there are other apps that have been developed since to submit field reports on avian species that birders encounter, and trying to get some sort of sense of the global biodiversity of birds in different parts of the country, tracking migration routes and monitoring population sizes and so forth. There are all kinds of nature observation applications that people use. Wildbook, iNaturalist, cicada hunt is a big one this summer because the cicadas are out. iBats. And it's sort of like they're like massive multiplayer Pokemon Go style approaches to wilderness conservation with humans as intermediaries between nature and artificial intelligence. So that's one particular application. Another is precision agriculture. So using AI-powered analytics to manage farms more sustainably and still increase crop yields using satellite and remote sensing technologies guided by algorithms, optimizing the use of water and energy and pesticide inputs and fertilizer. That would be another one. We're also using artificial intelligence in like intelligent transportation, obviously with highly automated vehicles. That will usher in an era of unparalleled ease, safety, and economy for the planet's drivers. But one of the concerns is that it could also lead to overconsumption because people could potentially engage in mega commutes and sleep on their trips into the office or to school each day. And we want to make sure that that we don't encourage or push workers to make those sorts of trips. And so, trying to develop tools, particularly regulatory tools that the Highway Traffic Safety Administration can use would be a best practice of AI. There's also some really interesting work in what they're called eco-bots. So eco-bots are cheap and effective robots, either on legs or that swim in the oceans, that could be used to remove species that have invaded habitats where they don't belong. So there's a tree bot that can climb trees and grab insects that are invasive species. There's something called Guardian, which is a device that protects endangered Atlantic reefs. It actually has like an AI hunting tool that will kill invasive lionfish. Queensland University in Australia has something called COTSbots that attacks crown of thorn starfish that are preying on the native coral polyps of the Great Barrier Reef. So the individual impact right now of these AI technologies is kind of small, but I think that they have a lot of potential in the future.
Yeah, that's an interesting perspective on AI and environmental conservation. Now, shifting gears slightly, I'd like to ask Dr. Wang, what limitations or challenges have you encountered when applying AI to engineering problems?
Yeah, thank you for this question. So actually, we also, as I mentioned, we are focusing on the wireless communication development, and traditionally we only focusing on the signal processing, and we realize that actually AI can be used to solve some traditional communication problems. And for example, as I mentioned, the modulation classifications. But one of the limitations we are looking at is the data. Because for the AI successful, for example, the ChatGPT or other foundation models, it's based on the big, super big model and a lot of the data sources. And here the problem for the communication domain people is a lot of the commercialized communication data is owned by the the wireless communication operators, AT&T, Verizon. They don't want to share to the public, right? They want to keep the data as it is their own resources. And one way to train our model is either through some simulation model to generating a lot of the the fake data. It's not the real data to mimic the real data. Or we can need to consider some domain adaptation of all the so-called future learning, because we cannot rely on such a huge data sets. We don't have access to the huge data sources to train our models. So that is what we saw for one of the critical parts for training successful AI models to replace the current communication system. Another critical things what I want to mention here is, so for example, people in communication, when the AI jump in, they are very ambitious, saying that we can using AI to replace everything, replace all the cellular towers, base stations, all your cell phone systems, right? But it's so-called end-to-end communication system. So end-to-end means from one end, which is transmission, and to the receiving end. Everything between will be replaced by the AI technology. But looks like it is very, very, very complicated and a challenging task, because the people doing the communication system for decades, from 1G, 5, 2G, right now we are in 5G, and we are jumping to the 6G. It's really hard for the telecommunication operators to replace everything. We need to go step by step. So how we can do this step by step? We need to pay a lot of attention to the merge between the AI technology to traditional communication systems, right? So this is quite a challenging task. So one of the solutions we can consider with is, how about we replace small components step by step. For example, one of the project what I'm working with is called resource scheduling. And we are not saying that we replace everything. We are take a look at all the current communication systems. It is fantastically working well and built on the Shannon equation, a classic mathematical equation bounded. And we are not replace everything. We're only looking at one of the iteration procedures. So because for the iteration procedures, it takes a time and costs a lot of the computation burden. So one of the advantage for the neural network or the AI is they can, maybe through the feed-forward process, they can replace this kind of iterative process. So we simply replace these small components and add it onto the current communication systems. So that is another important things. A few other things I can recall, including the social influences, because the social awareness things. For example, you can, let's try to give you an example saying that, consider for the autonomous driving, the self-driving cars, right? And if you have the self-driving car functioning on the highway, and if you consider a scenario, and because it's controlled by the machine will malfunction sometimes, right? And if we have a scenario in front of you, there's 1 people in front of you and another 10 people on the right. Will the vehicle will just moving forward to hurt 1 person, or moving right to hurt another 10 person, right? This is the very social problems, and how we integrating these social problems into the AI technologies. So that is what we call the social awareness AI. And another critical thing is the AI, to understanding the AI, because we have looks like the AI or the neural network is more like a black box. We simply train the model, and we have such a large language, the neural networks and components to train us very good models, but we don't know why it works, right? We need to understand better. Instead of we consider this is a black box, we need to put a more effort to understanding better for the current AI models, because in that way we can better help to design general models for not only for communications, but also for the climate change and multiple different applications. Yeah, so that is few thoughts from my side. And if any other professor you have anything else, you can feel free to add. Yeah. Thank you.
Great. Thank you so much, Dr. Wang. It's really interesting how you mentioned how a solution to the difficulties with replacing everything with AI can potentially pay more attention to the merge between traditional communication systems and AI technologies and taking them on in smaller components. Now to shift gears, I would like to ask Dr. Klein, in what ways do cultural beliefs and values influence the acceptance and implementation of AI technologies in different societies?
That's a great question, and I think I'd like to broaden out, just talk about how cultural beliefs affect the acceptance of technology in general. Certainly, some cultures are more amenable to technological change than others. This is neither good nor bad. This is just a difference. I think the key for technological acceptance is seeing the technology through the lens of a previous technology, and even using language to help make that connection. For example, automobiles were first called horseless carriages in order for people to understand the relationship between the automobile and the previous technology of carriages being pulled by horses. You can see the same with personal computing. Think of the ideas of the desktop and files, which are kept in folders. This all harkens back to the office and the way that offices were organized, where you had a desk with a desktop and you had all your files organized into folders and readily accessible for you. So I think a lot of it has to do with how it's couched and the language that's used. Specifically for AI, there's been a lot of groundwork laid for AI through science fiction, usually very negative portrayals, over sensationalized portrayals, so that there is a real fear on the parts of many that AI might turn into this sentient being that would at best ignore humans and at worst want to destroy humans. You know, that's the idea of the singularity, where computers and would no longer need humans to evolve. I think a greater threat is really losing your job, because they figure out a way for AI to take over the functions of what you do in the workplace. I think that's a much more realistic possibility, and one that, of course, is distressing to people. How it would impact negatively their ability to earn a living and provide for their families. But there is no unified way of looking at it, and I appreciate the idea that you need to look from a cultural perspective to best understand how technology functions in that culture and how it's adopted and how it's reacted to.
Yeah, thank you. So I think it's really interesting how you mentioned how, all different cultures have different takes on AI, and it's not just a single thing, and how we kind of have to like ease people into using AI and ease people into not having a fear of AI anymore. So, Dr. Lindsay, can you explain more about your work using artificial neural networks to understand the brain? What are some ways that you apply machine learning to climate change issues?
Right. So for the neuroscience side, as I said, there's kind of a long history between the study of biological vision and the study of artificial vision or computer vision. And basically the kind of current default model for computer vision, the convolutional neural network, some of the basic operations and structure of it are inspired by what was learned about the mammalian visual system back in the 50s and 60s. So there were some basic principles that people learned actually by studying cats and their neural responses to visual inputs. And that kind of slowly worked its way into the engineering community and led to convolutional neural networks. And so now today we can build these much bigger convolutional neural networks, deeper ones. We can train them to do visual tasks. So you can actually, put in an image, you get out a label or something like that. And that's kind of a big deal. Well, it's a big deal for computer vision, obviously, when that started to happen, because that's what you want computer vision to be able to do. But also, it's kind of a big deal for computational neuroscience and understanding the brain, because then now we have a model that we know kind of works like the brain in terms of, the basic operations it's doing. And we can actually give it tasks the same way we would give a human in a lab a task. You can show the model and the human the same image. And you can do behavioral tests and see, do people respond the same way as the model? Do they label it the same way? Do they make the same kind of errors? And you can compare the neural activity. So you can say, does this region of the brain, does it produce neural activity that is in some way similar to this part of the model when they're shown the same image? And so that's kind of the style of work that establishes that these models can work as models of the visual system. And then my particular work is a little bit more focused on understanding actually how the visual system changes under different circumstances. So for example, if you're looking for your cell phone and it has a blue case, then your visual system changes in a way that makes it better at detecting like blue rectangular things. So your visual system has this ability to kind of reconfigure itself on the fly, which we refer to as visual attention. And so I use these models to study what could be the mechanisms of visual attention, what changes about the neural activity could make the visual system better at specific tasks at different times, and kind of what are the principles of that. And so that again involves kind of reading, neuroscience studies that talk about what happens to neurons when we're doing that kind of attention task. How do the neurons in the brain change? And kind of translating that to be able to put it into the model, kind of do the same thing in the model and see if it has a performance benefit for the model. And then you can kind of loop back and forth between the model, and then that can inspire new questions to ask about the brain, and then use more data to refine the model and all of that. So that's the kind of basic setup for what I'm doing on the neuroscience side. On the climate side, and I should note, it's kind of the fact that I have these two very separate lines of research is kind of non-standard in academia. Usually people are pretty focused on one topic area. But the climate side, again, the overlap is the computer vision. So now we're using these models to analyze satellite imagery. So there's a bunch of satellites constantly circling the Earth. Some of them are run by the government, some are run by private companies, but there's a lot of satellite data. They go back, some of these satellites have been running for many, many years. And so there's a lot of information there, and there's a lot you can do with it. And so one project I have is on trying to understand the impact of beaver dams on the environment around where they're built. And so that we have locations where we know there are beaver dams, and then you can look at the satellite imagery and you can do all these other types of analysis on it to get other information out of it. And compare that to places that don't have beaver dams and see how it changes the vegetation and moisture and stuff like that. I have another project that's trying to track the development of solar panels in Puerto Rico, rooftop solar. So if you have a satellite image that's of high enough resolution, you can see individual solar panels on the roofs of buildings. And we're interested in how that has developed over time and kind of what neighborhoods have adopted this more than others. So these are the kinds of, very different styles of questions, but all the focus is all using computer vision to analyze satellite imagery in a capacity that's in some way related to climate change, prevention or adaptation to climate change.
Thank you for
That's
your response. So I really liked how you are like specifically comparing the model and the brain, and how you're trying to input something into the model to figure out how our brain works. Before we open the chat to our viewers, a few more general questions for our panelists. Firstly, what do you see as the biggest opportunities and risks of AI adaptation in your industry over the next 5 to 10 years?
I guess I can start for this one. So I believe people realize that, especially I know, I joined a research conference with other colleagues. Everyone talking about the foundation model and the ChatGPT, because the ChatGPT was like the superstar in AI and the booster. Because we didn't realize that actually the OpenAI, the ChatGPT can function so well. And we just want to see how the potential, the similar foundation model can be used to solve the traditional communication systems. So give you an example, what's a foundation model for the communication is because one of the critical challenges in the wireless communication is for the channel state information estimation, because you want to send in a signal to your friends, you need to understand or estimating the channel between the two locations, right? So there are multiple different scenarios. For example, the channel condition in New York City gonna be very different to the rural areas, and so the New York City, we have so many tall buildings, so the signal gonna bouncing back and forth, so making the channel very different to some rural areas, because in the rural areas, we probably have a line of the sight, so the signal can be transmitted directly to one place to the other. And some other example is like the Colorado, Denver, right? The Denver, they have the mountain near the cities. So a lot of the signal gonna bouncing back directly from the mountain to the users. So definitely the modeling the channel is a very critical and challenging problems. And we're using so many variety of the mathematical models to mimic the real channel models. But so far we couldn't find a general model to fit everyone. So we have to, in order to implementing the AI technologies for the future communications, which means we need to retrain our channel estimation model for different scenarios or cities. Is that possible? We can have this kind of the foundation model, which is we collecting the data from New York City's rural areas, Denver, any places, and under any weather conditions, the temperature difference, the winter, summer, so because the weather condition also affecting the channel conditions, and put them together to train a relatively good foundation model. And then for the good foundation model, we're using directly, we cannot directly apply the foundation model to the specific areas. We still need to do the domain adaptation and based on some very little or few short learning to adapting the model to quickly adapt it to your specific scenarios. And that could help the communication system a lot. So that is actually one of the research direction I was seeing. A lot of the research people are gonna jumping into how using the multimodal learning and similar learning technologies developed by the ChatGPT, like the transformers, into current wireless communication system design. Yeah, thank you.
That's fascinating how you can quickly adapt models to your needs. Now, how about Dr. Klein?
I touched upon this earlier, in terms of writing instruction. There are great opportunities. I don't think AI is something that should not be utilized, but I also don't think it should be used without thought and without some sort of specific purpose in mind. There are a lot of ways you can use AI to think about initial drafts of something and then use that as a platform or a jumping off point for you to then interact with the writing and then come up with ideas and still be able to think critically about what you are trying to communicate. I think the real danger is thinking that writing is just about stringing words together in a way that people can understand. There's so much more to writing. Writing has to do with understanding your audience and understanding their needs and building a bridge between what you want to accomplish and what they need for you to be successful. And computers can't do that. They don't have that lived experience that all of us as human beings have, so that when you're writing something, you have your experience of writing previously, you know what works, what doesn't work, and you're not just using an algorithm to comb through a variety of samples of writing in that situation. You're really thinking about what worked, and you have that empathy, which we haven't created artificially, for your audience members.
Yeah, thank you so much, Dr. Klein. I completely agree on your point on how AI shouldn't be used without thought and how it can be used to create a draft, but still be able to think critically about what you're trying to communicate with your audience. Okay, now moving on to our next question. How has AI affected the way you teach and or do research? Dr. Frana, can we start with you?
Sure, yeah, absolutely. So I think a lot these days, and this also relates to the previous question about the challenges that our national economy and global economy are going to face. So, um, I'm teaching young people today for jobs that are just about to disappear around the world. McKinsey estimates that something like 800 million jobs are going to disappear in the next 10 years. Fortunately, as another speaker here tonight said, there isn't a fixed amount of work and thus a limited number of jobs. We've already seen that 350 million jobs have been created to replace those that have been lost through generative AI. But have no doubt that jobs in the workforce will change, and that's normal. But what I share with my students is that what's not normal is making few allowances for the people that artificial intelligence could leave behind. I lived for a decade in Arkansas, and so the question that's always on my mind is, what's in it for people in the Mississippi Delta or the Ozarks? What's in it for people across Appalachia, just to our west? And I think this is the sort of thing that we need to be thinking about. But we're doing lots to prepare for altered circumstances, and I'm trying to make my students aware of these amazing certificate programs that have emerged. So tech giants and the government have already hatched a plan for reskilling 95 million Americans in the next 10 years. The group includes Google and IBM and Intel and Microsoft. And they have this new learning portal and platform called Skills Build, where they will offer free credentials in artificial intelligence basics. They're like these 10-hour online training programs called, for AI fundamentals. And so I think high school students and college students, all high school students and college students, should really think hard about whether those things are, might be pivotal in changing their approach to the different disciplines that they're working in, regardless of whether it's the health sciences or engineering or what have you. I think every major is going to be impacted by this. Anyone who is turned on YouTube and for instructions on how to cook or do car repairs or to figure out a coding trick, any of hundreds of other pursuits, knows just what the impact of the exploding field of artificial intelligence is going to be. And so I spent a lot of time with my students saying that, I may not be there to figure it out with you, but you need to prepare and make yourself, available to artificial intelligence developments in whichever direction they might go. And I don't think anybody really knows what the future might look like with artificial intelligence, but we all need to remain open.
Thank you, Dr. Frana. I agree that we should be thinking about what's in it for other people when some jobs will go out as AI expands and new jobs will also rise. I also think it's fascinating that 95 million people are being reskilled. And I agree that it is important to stay open as the future changes. So what about you, Dr. Lindsay?
Yeah, so when it comes to teaching, the main thing that has impacted teaching is the release of things like ChatGPT, where students can be using that, potentially without the knowledge of professors. And so that that unfortunately kind of makes teaching a little, I don't know, I would say a little bit sadder because you have to restrict the types of evaluations you can do if you're concerned about that. So there's a course that I teach that was kind of designed by the person who originally taught it to be resistant to this kind of thing, but it means we're doing a lot of like in-class quizzes and other stuff that maybe isn't the most optimal way to evaluate people. But there's always that fear that there's at least some small number of students who are going to, if they're assigned an essay, they're not even going to read what ChatGPT spits out for them. So in that way, it's unfortunate because it just kind of makes you a little bit more stringent in how you can grade and just reduces the types of assignments that you could give if you're concerned about that. But in some ways, it makes you have to be a little creative as well. So that's kind of a negative of it. I also, this one course that I teach, which is data literacy for psychology students, it actually does involve having to teach people about these models and how they work and how you should think about using them and kind of notions of trust around them and all of that. And so I think it's good. I mean, I'm happy that I happen to teach a course that actually lends itself to talking about these things explicitly. I also, in another course that I teach, which is about machine learning for climate change, students have to do a research project, and I show them, if you ask a chatbot for like references, like tell me papers on this topic, there's a good chance it's going to make them up. And so you can't trust it. Yeah, it's influenced my teaching because I have to bake in the explanation of these models to students. If they might try to use them, they should know their limitations and have some understanding of how they're generated and all of that. And then also, yeah, it kind of constrains the assignments a little bit. Yeah, and then so that's the kind of like language model side of AI and how it's impacted my teaching. And then of course there's just all the actual applications of other types of AI to the types of problems that I was talking about. And again, I have this like machine learning for climate change course where people do research projects. And so then we just get to explore kind of what I would say more fun and productive side of AI is in that course.
Yeah, thank you for your answers. So I really agree with your point on how educators have to watch out for students misusing AI, whether it be on assignments or on homework or on exams, that educators just have to be wary and watch out for students misusing AI. So one last question before we open the chat up to our reviewers. What skills do you think will be most valuable for workers as AI becomes more prevalent? Dr. Klein, would you like to answer this question? Oh, I don't think his
I'm sorry. Could you repeat that, please? The sound broke up a little as you were asking the question.
Yeah, sorry. So our last question is, what skills do you think will be most valuable for workers as AI becomes more prevalent?
Critical thinking, hands down, critical thinking, because that is something that can be applied in any discipline, in any work situation. Being able to look at a situation, think beyond the obvious, and come up with an answer to solve a problem. I think a lot of that is done. A lot of the learning of critical thinking comes from writing, learning how to write, learning how to communicate. But, and of course I'm biased, but I think critical thinking really is something that is applicable in so many situations and is a skill that employers are going to want to have, regardless if AI is being utilized fully or only in a minimal way.
Yeah, thank you, Dr. Klein. I agree that critical thinking is very important, regardless whether AI is used. So now I'd like to maybe Dr. Wang, could you answer this question?
Yeah, I think I also agree with this. I totally agree because one of the example I can thinking about is for example, the coding. People are saying that the coding is important for the future study, right? It is true, but it's not that true because we have the ChatGPT. They can help you to code the very fundamental and basic ideas. The only thing you're lacking with is how critical thinking, how you consider a problem, what kind of the solution you want to design, what's the logic behind solving this problem, right? You don't have to a very sufficient or very proficient coding skills to do these tasks in the future. Of course, right now, as a software engineer, you definitely need to be familiar with a lot of the different coding platforms, Python, whatever, C++. But right now we have the ChatGPT. So what you need to do is we call it a pseudocode. So you just need to list your understands the way you try to solving these problems through your critical thinkings. And then by translating your languages to the ChatGPT or whatever other generative AI technology tools, they can magically produce the code and solving that problem, right? So definitely the critical thinking is important. And another thing I also want to emphasize here is the social awareness. So the social awareness. So because of the AI, the ChatGPT was trained based on the data, right? The data can be biased. The data can be sent by the OpenAI engineers. So they want to train the model with the data they want to train, and they may hide the data they don't want to train, right? So they are going to have some bias for whatever the generative AI models. We definitely, for when we train the future AI engineers, social awareness and how to understanding the social connections is very important from my understood. So we definitely need to consider the social awareness AI for the future. Yeah. Thank you.
Thank you for your response. I found it interesting how you and Dr. Klein both mentioned critical thinking as being this really important skill that people will have to be able to develop as AI is increasing in our world. And because critical thinking is really how people think outside of the box and how people can think differently from AI, I think that's going to be a very important skill. And I also agree that social awareness is going to be very important because we know don't believe everything you read on the internet, but as AI becomes more prevalent, I also feel like we're going to have to be able to say to ourselves, don't believe everything you read off AI. So now we will open up the panel for any questions from the viewers. Feel free to type your questions in the chat.
Okay, so it looks like we have one question. So, to what degree do you think AI exacerbates inequalities within people?
I think what the person is asking is creates greater inequalities amongst people immensely. We've seen time and time again that the data that's loaded into algorithms is bias. It represents the biases that are inherent within our society and just exacerbates them. So that is something that we have to be extremely careful about, that we don't replicate and amplify the biases and the discriminations and the inequalities that are present in society, amplify those within AI itself, because it's happened and it can continue happening unless we're very aware and take concrete steps to stop doing that.
Thank you, Dr. Klein. So the next question is for Dr. Lindsay.
All right.
So
I was just going to add to that last one. It's also the case that, especially like these large language models, they require so much data and so much compute power. They can only really be trained by like some of the biggest tech companies. And so then you have this very small, set of options that everyone has to use the same model. Even if you see kind of a different product, a lot of times it's using ChatGPT, behind the curtain. And so I think that's really a problem too, in terms of people having disproportionate access to being able to build these models, to use for different purposes and all of that.
yeah, okay, thank you. So back to the question I was asking. So applying computer vision to analyze satellite data is super useful. Is it true that computer vision has been relatively mature? Would you please list a couple of hard problems you encountered in your research so that we have a better understanding about the essence of your work?
Yeah. So yeah, I mean, computer vision is it was on the early end of like the AI boom, starting around 2012 is like, this is when kind of these new approaches of deep learning and artificial neural networks really started to take off. And that was a computer vision problem that was kind of solved that led to that, kind of all that attention and stuff. So yeah, computer vision, it is mature and compared to some of these other things in AI for sure. It's not solved by any means. We still don't have computers that can analyze visual scenes as well as humans, given all the different things that humans can do with their visual system and ways that they can analyze a scene and all of that. And so in this kind of research, yeah, so the difficulty actually comes from a few different parts. One of it is actually getting the data into a format that's conducive to use computer vision on. So this, as I said, these satellites have been around for a long time. People have been using them in a kind of more small scale way of actually, like, you pull the satellite image and you actually look at it yourself, or you only do very basic visual image statistics on it. You're like, people weren't doing super advanced computer vision, when they started using satellite imagery. And so just the infrastructure around it isn't always the easiest to actually get the data that you need and put it in the format that would be good for computer vision. And you have to deal with things like clouds and stuff like that you have to filter out and everything. So as is the case with a lot of data science problems, it's actually getting the data into the right format and making sure you have good quality data that can actually take most of your time. But once you do that, then yeah, to some extent there are solutions to the problem. So for example, I put a link to a paper because someone was asking for more details about the solar panel project. But for that project, we're relying on a model that other people built that was trained on a lot of data from the United States of images of solar panels. They didn't apply their model to Puerto Rico, so we're hoping that we can take that model and apply it to imagery from Puerto Rico and do a survey of solar panels there. But the imagery that we're going to get, the satellite imagery that we're going to get, is not exactly the same satellite imagery product that was used in the original study. And with machine learning and AI, the model is suited for what it was trained on. It knows what it was trained on. And if you change what you're inputting into the model so that it's not exactly the same as the stuff that it was trained on, it might work differently. And so you could broadly say, oh yeah, we have a model that detects solar panels and satellite imagery. Great, problem solved. But when you apply it to a new situation, it might not actually work as well. And then we're going to have to figure out why, and we'll have to tinker with the model to make it work in that particular situation. So a lot of the difficulty, at least in the types of projects that I've been engaging in, is a little bit more in the details. Maybe broadly, what you need to do to solve the problem, but actually getting it to work on your specific data set and getting it up to a level of performance that's actually needed to rely on it. That's where a lot of the work is. So there's still a lot of open problems in actually doing the application. There's a lot of basic research that kind of makes it seem like maybe there's been so much progress that everything's solved. But when it actually comes time to applying it and getting a high level of quality out of it, there's still a lot of work usually.
Thank you very much, Dr. Lindsay, on your insight into solar panels and sharing how there's still a lot of room to work on the difficulties with actually doing the applications. And thank you all for your thoughtful questions, and to our panelists for sharing their expertise. And that would conclude our panel discussion. Thank you once again to our outstanding panelists and to all of you for attending. We hope this workshop has provided valuable insights into how AI is shaping various industries in our world as a whole. If you'd like to learn more about BranchOut and our future panels, please check us out at www.bellbranchout.org or like us on Facebook at Veritas Education Leaders. For updates on future workshops, feel free to follow us on our social media platform given in the chat.
Thank you everyone for attending, and we invite our panelists to stay for a few minutes after for a group picture. Have a good night to everyone.